All right, in this problem, so we got Jamie and Kit, and they're building a wall together. They can build the wall together in 4.5 hours. So it takes them 4.5 hours to build this wall. And Jamie can do it by herself or himself in 6 hours. So the question is, if Jamie can do it alone in 6 hours, but with Kit's help, it only takes 4.5 hours, how much help is Kit giving? And so, like, if Kit were to build the whole wall by him or herself, how long would it take? Now, these types of work problems, they're classic and they're very confusing. So there's lots of different ways to approach this problem. But one is I kind of like to sometimes draw a picture. And it helps if I might give the wall an actual size. All right? So, well, this wall, I'm going to make 18 squares, right? 18 squares. So this right here would be Jamie, and Jamie plus Kit over here, right? So 18 squares, and Jamie can do it in 1, 2, 3, 4, 5, 6 hours. And Jamie and Kit together do the same 18 squares. Notice this is 6 by 3 is 18. This is 9 by 2 is 18. So they're different shapes, but it's the same number of squares. And Jamie and Kit together can do it in 1, 2, 3, 4 and a half. All right, so I've taken the 18 squares and divided into 4.5 pieces of the same size with this little extra half piece here. And I've also divided into 6 equal size pieces. So this is what Jamie does each hour for 6 hours. And here's what Jamie and Kit together do in 4.5 hours. And so you look at the two diagrams and think, well, like, you know, how did the piece sizes compare? How does adding Kit's extra little bit of help change each hour's worth of work? Okay. Now, of course, one thing you want to think about here is I picked 18 squares. I picked that for a very specific reason. You want to think about why I picked 18 squares. Why is that a good number to pick? I mean, why wouldn't I just pick 6 squares? Right? Because I could just say, well, Jamie does 1 square per hour. Why is it 3 squares per hour for a total of 18 squares? Right? So if you look at the two diagrams, you should be able to figure out what Kit's contribution is. But also you'll want to come up with a method that is more, I guess, repeatable than what we've done here. Or at least figure out where the 18 squares comes from so that we can, maybe if we come across a similar problem, you could draw a similar diagram, but probably with a different number of squares. Huh?